Everybody, can you see my screen? Okay, good.
Yes.
Okay, so today we will start the new chapters. I think we are almost 80% of the syllabus are done. Now remaining 20%. So there are 3 chapters remaining. This is one chapter, two-port networks. Then there will be a Fourier series and Fourier transform application to circuit problems. And then the last one will be three-phase circuits. So I can say about 20% of the syllabus is remaining. That I will be covering in next 2 to 3 weeks. So, the two-port networks. So as I said, the two-port network is defined as an electrical network with two separate ports for input and output. Therefore, for example, so far in most cases, you have learned this type of circuit. You see, linear network, it is written, and you had two terminals. This is one, this is other, which is called the one port. So the definition of port here means there will be two terminals. For example, in this case, this is plus terminal, minus terminal. Current is entering, but here current is leaving. That is the in most cases series circuit, parallel circuit that you have noticed, except the magnetically coupled circuit that is just covered up to the previous class. So see this on and then see the bottom figure. Again, the linear network, whatever the component is, resistance, inductance, capacitance, whatever the component inside, here you can see there are two terminals here, another two terminals here. Therefore, left side, two terminal, this makes one port, right side, this is another port. And this is called input port. This side is the output port. And as you can notice, on the left side, first port, current is entering ion and then current is leaving ion, like similar to this one. But on the right side port, from this terminal current I2 is entering and then current I2 is going out. So, and these are the separate things. And they are both ports, left side, right side port, they are interrelated with the help of the components which are inside this linear network. So this type of circuits are called the two-port network. I mean, there can be multi-port. Again, there can be another linear network like cascading type of output of one circuit is the input of the next circuit. This is called the cascading or the ladder network. But in this chapter, we will be learning only up to two-port, not the multi-port. But in real practice, there are multi-port network as well. Now, the best example of this type of network is magnetically coupled circuit that we just covered. I mean, until your exam, the last class, or the transformer. You see, transformer has the primary, for example, this one, and then there is the secondary. So transformer or magnetically coupled circuit is the best example of this type of network. Also, I believe in electronics, you have studied transistors. I think you all know transistors, right? There is base, emitter, collector. So like base and emitter is the input, and then the base collector is the output, whatever. And then also the operational amplifier, op-amp. Operational amplifier is also the example of this type of network. Because in case of op-amp, there is input terminal, there is output terminal. So therefore, transformer, operational amplifier, transistors, those are the example of two-port networks. Now, why are we learning? As I said here, the two-port networks are very important, especially in communication network, control system, electronic circuit, and then in general, the power network, power systems. So these are the reasons we will be learning the two-port networks. Now, this two-port network, like input port, output port, as I said, they are related through the linear network components. Therefore, This is current, these are current, this is voltage, this is voltage. So you all know that voltage and current are related with the help of the impedance or admittance. That's why here I have written impedance parameters, admittance parameters. So therefore impedance is applicable in case of series circuit and admittance is applicable in case of parallel circuit. Therefore definitely here linear network, here there are impedance or admittance. So if it is parallel network, we will concentrate on admittance. If it is series, then we will say the impedance. So now that will be the question, and that is the most important thing for this chapter, that how we can know, how we can determine the impedance or admittance parameters for this type of two-port network. So that is the thing we will be looking and concentrating from now on. So therefore, moving forward, so everybody say here, what I am doing, I am determining the impedance parameters for two-port network. So now, as you can see, I have shown figure. It can be, there is a voltage source here, there is a voltage source on the second port, and current is entering ion here, current is entering here I2. Or this could be that there is current source here, current source here. So accordingly, there is voltage here and there is voltage here. So therefore, network could be this structure or could be this structure. So therefore, whatever it is, first let's have a look how we can determine the impedance parameters. So therefore, everybody look the left side network. Let me make it big it little bit. Okay. So everybody concentrate on this on left side. This is voltage and current entering ion. And here the voltage source is V2 and current entering I2. So look my equation. Definitely, as you can guess, that this first port is related to the second port through the impedances. So accordingly, I can write general equation. Everybody look that V on here, G11 ion. This means this current multiplied by the G11. So and here I have written down the definition at the bottom. You see what is G11? Open circuit input impedance. So I am coming that point. I have written down the meaning of all those. Okay. So Gi ion multiplied by ion plus G12 multiplied by I2. So therefore there is one impedance G12 is the symbol. G12 means transfer impedance. For example, G12 open circuit transfer impedance from port 1 to port 2. Therefore, that is the relationship between port and port 2 through the G12 and multiplied by I2, the other port current. Similarly, we can write that V2, see, G21 ion plus G22 I2. This means it has its open circuit output impedance. What is the impedance at the output port? That is G22 multiplied by its current. And then this port is related to this port, first port, with the help of through that G21. Therefore G21 is open circuit transfer impedance from port 2 to port 1. That is ion. So therefore these two are the generalized equation that represent this two-port network. Therefore from here, as you can see, or in matrix form, I am forming the matrix. So V1, V2, and then look all impedances G11, G12 here, and then G21, G22 here, and then definitely ion I2. Or briefly, you can say this is the G matrix or G parameters, and then ion I2. So now the question is, you understand this is V1, V2, ion I2, but how to get those four parameters, G11, G12, G21, and G22? Those are called the impedance parameters. So soon I will show you numerical problems. Then I will show you the example, how to do that. So in the problem, you will be asked, find out the impedance parameters of the two-port network. So impedance parameter means everybody, you will assume that you have to find out these four parameters: G11, G12, G21, G22. Now the question is how to get that on? How can I calculate? So that is the thing we will be looking, determination of impedance parameters. We want to find out. So that's why here everybody see, this is the method. So these two figures, A and B here, they are representing how to do that. Now, I understand that this is the generalized equation. From here, look this circuit. So as you see, everybody see, I wrote down these two equations based on this network A. So now, with the help of this network, I will find out G1 on G21. So everybody see what I did here. Look, left side I have the voltage source, but on the right side I have kept it open. I have made it open circuit on the right side. This means that because the right side is open, meaning that there is voltage, but current is zero. That's why I say I2 equal to 0. This means that in the problem, when you will be finding G1 and then G21, you will make right side port open. Port number 2 is open. So that's why you see G1 is V1 over ion. G21 is V2 over ion. So how to do that? Look everybody the first equation. Because right side is open, meaning that I2 is 0. Therefore, in the first equation, put I2 0. If you put I2 0, then what you are getting? You are getting V1 equal to G1 on ion. So from there, G1 on is V1 over ion. That is the thing is written here. Then how to get the G2 on? The same thing. In the second equation, again put I2 0 because right side is open. So then again you are getting G21 V2 over ion. Then similarly, you have to find out the other two parameters, G12 and G22. So how to do that? Now this time everybody see, you keep this port, you put this voltage source as it is, you make open this one, you keep it open. So that's why in this case you see V2 source, I2 current is flowing, but because first port is open, this source is open, consequently ion is 0. Now based on that, now in this again in this two equation, now put ion 0, because it is open. If you do that, you are getting G on to V1 over I2. You see, that is the thing written here. And similarly, G22 is V2 over I2. So then by using these techniques, by keeping it this port open or this port open, you are able to find out all those four parameters. So this is called the method to determine the impedance parameters. So therefore soon I will show you numerical problems, 2 to 3 numerical problems, then everybody will be fine how to do that. So far everybody, do you understand? Could you follow me?
Yes.
Yeah. So therefore now everybody, this is the theory in terms of theory. Now let's take an real example, then everybody will be fine. Okay. Now everybody see the problem. Determine the G parameters. G parameter means the impedance parameters for the following circuit. Now this is a circuit. There is 2 ohm, 30 ohm, 40 ohm. These values are given. This is the port number 1, 2 terminals. This is the port number 2. Now with respect to this circuit, find out the G parameters. G parameter means find out those 4 points. G1, G12, G21, G22. So exactly we will be following these two methods. First we will apply this technique. We will assume that there is voltage source left side, right side is open. Next time we will assume that there is voltage source on the right port, but left port is open. Exactly we will apply this technique. Now everybody say this is my circuit. So first assume that there is voltage source here, but this side is open. Now everybody see, exactly I am doing this thing. Now see this one. I assume that there is voltage V1, current flowing is ion, that 20 ohm, 40 ohm, 30 ohm, this one, this thing, 20, 30, 40, that I have written down here. And right side is open. You see, like this is my handwritten. So initially I closed and then I opened it. It is open actually. So that's why you see I have written I2 equal to 0, but this is V2. Now, now find out what you will find out from this one. From the first one, if you keep right side open, you will be getting, look, G on G2 G on G2. So write down those two expressions. So therefore, everybody see, I have written down G1 is V1 over ion, and then G2 is V2 over ion. Now the thing, now look this network. What is V1? Look this network. V1, because current flowing is ion, this is 20 ohm, this is 40 ohm, 30 ohm, and of course this is open. Based on that circuit, everybody say, what is your V1? So meaning that V1 will be this current ion multiplied by what is the equivalent impedance, right? So V1 will be that one. So V1 is ion multiplied by what is the equivalent impedance. Now, what is the equivalent impedance? Everybody say, because this one is open, so meaning that no current is flowing through 30 ohm, right? So this means you can neglect it on. You don't need to take into account 30 because no current is flowing. So therefore, then these two is in series, 20 plus 40. So therefore, your impedance is 60 ohm. So 60 multiplied by ion, that is your V1. So therefore, everybody see, I have written down here, it V1 is this ion multiplied by this 20 plus 40. So that I am plugging here, V1 ion. And then in the denominator, I am just keeping ion. So you see, ion cancelled, your result is 60 ohm. So meaning that G on is 60 ohm. Now look G21. What is G21? V2 over ion. So what is V2? Here it is V2. But it is open circuit. So this means that ultimately what you are doing, you are measuring the voltage across 40 ohm. Look, if you connect a voltmeter here and here, because this is open, so no current is flowing through 30 ohm, clearly shown I20. Then your voltmeter will read what is the voltage across 40 ohm. So this means that I have written what is V2 then? 40 multiplied by ion. Now you see, because the source is here, so current ion is flowing. So because this side is open, so this will be your circuit. Current will flow through only 20 and 40. So therefore that ion current is going through 40. So that ion multiplied by 40, that will be actually your V2 here. So that is the thing, 40 multiplied by ion. And then denominator ion cancelled. I got 40 ohm. Could you follow me, guys, everybody?
Yes.
Yeah. So far, I mean, this is not any difficult thing, just the simple circuit problem. Once you can write, your task is you just need to write down those expression correctly, G1 on G2, and then you look the network, what is available. I mean, in this case, this is the circuit. Again, I will show you different network. From the circuit, just you have to find out what is V1, what is ion, that's all, based on the circuit and your previous knowledge, series parallel concept, that's all. Okay, now look this one. Now I will be finding out the other two parameters, which is these two, G onto G22, or from the equation, these two parameters. Now, this will be my technique. What is the technique? I will be keeping left port open, but I will be applying the source on the right side. So therefore, everybody see, I am applying the source V to right side. Now current flowing is I2, and my element is the same. That was here, the 20, 30, 40, which was given. My element is the same. And then this side is open. This means V1 is 0. So, sorry, so ion is 0. and there is V on, voltage here. Now, what is the G22? V2 over I2. Like how I get that? This one. G22 V2 over I2 and G1 to V1 over I2. So everybody see? Now look this network. What is my V2? So now this time current is flowing. Again, you see this side is open, meaning that ion 0, no current is flowing through 20. So therefore, I2 is flowing through 30 and then going through 40, and then this is the network because this side is open. So what is your V2? V2 is I2 multiplied by 30 plus 40, which is 70. So therefore, exactly you see, for V2, I have written 40 plus 30 I2, and then the denominator I2 cancel, 40 plus 30, 70 ohm. So I got the value G2 to 70 ohm. Now, what is G on to? G on to is V1 over I2. That is my definition. V1 over I2. Now everybody see, now I have to get this voltage. What is V1? But then again here you see no current is flowing through 20 ohm because ion 0. So V1 means voltage across the 40 ohm. Everybody see V1 means measuring voltage across 40 ohm. So but how you will get that? You see that the current I2 is flowing through it, through 40. So 40 multiplied by I2, that will be your here V1. So therefore everybody see I have written V1 is 40 multiplied by I2. And then in the denominator I2 cancel, I got 40. So therefore one interesting thing, can you see? G1 has 60, G22 has 70. Here you see G2 on 40, here G12 is 40. And that makes sense because G2N is that transfer, open circuit transfer impedance from port 1 to 1, sorry, from port 2 to 1. Similarly, G12 means open circuit transfer impedance from port 2 to 1. That is the meaning. That's why G21 and then G12 are the same. So now these
And that's
four,
always the same?
yeah, it will be always the same. Now here you see that I'm writing in the impedance format. You may not need to write, I mean, during the exam or homework or whatever. If you can just calculate these four, then you are done. Just I am showing this one because like I did it here. That's why, sorry, this one. That's why I am showing that one. But you don't need to show this one. So the four parameters, that's 60, 40, and then 70, and then this 40, G12. So I think everybody understand, right? I mean, this is not difficult. Just depending on network, these values will be changed, or there can be another parallel branch, etc. So this might look like different, not exactly this pattern. But by looking the network, if you can calculate what is V2, what is V1, then you are done. Is everybody fine?
Is this kind of like superposition?
Not exactly superposition. It looks like superposition. I mean, considering one source at a time. So kind of similar to superposition. But in case of superposition, you are asked to find out voltage or current at a particular branch. So this is not voltage and current measuring. In this case, you are measuring those impedance parameters, those four parameters. So that is the technique that when you will be calculating these two, G1 and G21, you make it I2 0. That is the thing. When you will be calculating these two, you make ion 0. So ion 0 means, okay, the left side port, keep it open. That is the thing. So the similar meaning, but not exactly the same thing.
Cool.
Got it? Yeah. Okay, so therefore everybody see one more example, then it will be much more clear to you. Another thing, yes. Is in this case, okay. So the Julian, like just few minutes ago, a minute ago, like he asked that thing, always it will be the same. Because in this case, it is the impedance in terms of the, that's why you are looking the different things. Those were the resistances. Resistances always the same, G1 to G21. But in this case, because in the impedance form, so this is different. So everybody see, in this case, sorry, let me see. Yeah, in this case, what is the question? Question is, find out I1 and I2 in the following circuit. Now, yeah, I mean, in the previous case, this was the circuit, we calculated G parameters. In this case, look everybody, G parameters are given. G1 on 40, G1 to J20, G2 on J30, G2 to 50 ohm. So those 4 parameters are given. Based on that, find out I1 and I2. Also, this is given. Left side voltage 110 degree, sorry, 100 degree, and right side there is a component 10 ohm. So this is the circuit. Based on that circuit, find out I1 and I2. That's the question. But those parameters are given. So this means that because those parameters are given, and here I know V1 and this is V2, I just need to write down those relationships. What is G on? G on is V on over I on. If I can write down, then I can relate, I can calculate. Just you have to write down those equations. What is G on G on to G2 on G2 to, and you relate, then everything will be related. And just by calculating, you can determine what is the value of I1 and I2. So therefore, everybody see this one. Okay, so here are that calculations. Everybody see? First, I wrote down that basic definition of V1, generalized equation that we have learned. What is the V1? Sorry, V1? G1 multiplied by I1 plus G1 to I2. That generalized equation that we have learned today. This thing. Exactly, I am writing these two equations. Okay, and then plug in those values. V1 is 100, 0 degree. What is G on? G on is 40, that is given, ion. What is G on to? J20, write J20, impedance format I2. So this is my one equation. I can see the variables ion and I2, which I have to find out. Write down the other equation. V2, G21 multiplied by ion. Then plus G2 to I2. Now plug in those things. Here you see, what is V2? V2 is the 10 ohm was given, then 10 multiplied by I2. But then this is in opposite direction with respect to this one, in this direction. That's why minus 10 I2, that V2. And then what is G21? G21 is given J30 ion. What is G2 to? 50. This was given. Now I got second equation. So from these two equations, find out ion and I2. So from this equation, I simplified. I wrote J30 ion, look, equals to, this is 50 I2, this is 10 I2. I took this on this side. So then I got minus 60 I2. So from there, I am calculating ion. So I got ion J2 I2. And now you plug in, substitute ion this one in this equation. So if I am doing that one, look, this is 100. I am not writing 0 degree anymore because this is 0. And then 40 ion value, this one J2 I2 plus J20 I2. So from there, I got, after calculating I2, 1 at an angle of minus 90 degree ampere. And then substitute I2 this value here. So I am getting J2 multiplied by this minus J1. So you are getting 2 at an angle of 0 degree. So I am done, ion and I2 value. Everybody, could you follow this one? Sorry. Could you follow?
Yes.
Yes.
Yeah. So just it's the calculation. What is this thing cam? Hold on. So therefore now, based on that, what you do, what I would recommend you. Okay. Now, so far we looked the impedance calculation. Now look the admittance calculation. So first let's have a look. This one. Let me switch. This one. Determination of admittance parameters. So therefore, when it will be the admittance, so therefore everybody look this on the network B. Assume that there is current source I1 here, then current source I2 here, and voltage V1 available here, voltage V2, and then again there is linear network. It is related to those impedances. So find out. But in this case, because current sources are given, so we will be writing equation in terms of admittance. Therefore, everybody see this one, because my ion is given. What is ion? Ion is Y1 on V1. So you all know the admittance. Admittance multiplied by voltage, that makes the current ion. Because you know admittance is the reciprocal of impedance, Y equal to 1 over G. So similarly, then ion is Y1 on V1 plus Y12 multiplied by V2. Similarly, I2 is Y21 multiplied by V1 plus Y22 V2. Then again, you can express this one in terms of matrix I1, I2, and then those four parameters Y1 on, Y12, Y2 on, Y22, and then V1, V2, and then briefly Y matrix or the admittance matrix. So then now what is the definition of Y1 on, Y12, Y2 on, Y22 that I have shown here? Y1 on means short circuit input impedance. In this case, those are the short circuit. In previous case, those are the open circuit. But in this case, you look, all are the short circuit. Short circuit input impedance, Y22 is short circuit output impedance, and then short circuit transfer impedance from port 2 to 1 or from port 1 to 2, Y1 to Y21. So therefore, everybody keep in mind, in case of admittance parameter calculation, you have to apply the short circuit concept. Now, here is that technique. This means that you will be getting this type of circuit. Left side you have the source. You assume that right side is shorted. Because right side is shorted, so your voltage is 0. But there is current flow, I2. So why it is short circuit? Because we want to find out, similar to previous case like Y1, Y21. So how to do that? We have to make V2 0 here. So what is the way to make V2 0? Because this is voltage, you have to make it short. That's why. In the previous case, impedance parameter calculation, there was current term here, voltage term was here, V1, V2, but there was ion I2 here. You needed to make I2 0. I2 0 means you need to make the circuit open. That's why for impedance calculation, these were the open, either here or here. Now you have to make voltage 0. That's why you need the short circuit. That's why these are called short circuit input or output impedance or short circuit transfer impedance. Now everybody see, when you will be finding Y1 on and Y2 on, you will be making right side port short. This means V2 0. So if you make, you look the equation, if you make V2 0, this means you will be getting Y1 on ion over V1 and Y2 on is I2 over V1. Similarly, next case, to find out Y1 to Y22, you will be making left side first port short circuit, and then you apply the current source on the right side. I mean, as it is, just make short left side. So therefore, if you do that, this means now your V1 0. So in the equation, look, this basic equation, if you make V1 0, then you will be getting Y1 to ion over V2. That is ion over V2. Similarly, Y2 to I2 over V2. Now, based on this technique, you can find out the admittance parameters for a given network. That now we'll be looking. Everybody, could you follow me so far?
Yes.
Yeah. Okay, these are pretty interesting. I mean, and not difficult. Just what you do, like everybody, you will be keep these things in hand, or you can remember this one. Then you write down this expression or for impedance that previous expression, and then you know that you have to make short this side next time this side, or the previous case you have to make this side open and this side open. That's all, and then you say how you can do. I mean, easily you can do those things. You can write down those expressions. Now we want to apply this technique to calculate the admittance parameter for a given network. Therefore, everybody see one example. Everybody see. Obtain the Y parameters for the following pi circuit. Oh, so I believe you know that this looks like the pi symbol. That's accordingly it is called pi circuit. And this looks like the T symbol, T capital. Accordingly it is called the T circuit, although it is not written, but keep in mind sometimes this is called the T circuit, and this one is called the pi circuit. Now for this pi circuit, find out the admittance parameter, Y parameter. This means that in this case you have to find out Y11, Y12, Y21 and Y22. That is the thing. So everybody, can you try this one at your pen and paper? How to do that? So this means that everybody, you will assume that first there is current source here, ion is here, and there is V1, but right side is sorted out. The next time you will assume that there is current source I2 here, there is V2, but then this side is sorted. So then can you calculate the Y parameters? What I would recommend to everybody, please write down this one. Please write down everybody this circuit V. Please you draw and write down these these two equation, and then write down these two, and then you take your pen and paper and you try that one. Everybody, please note down or take a photo or take a picture of this slide, these things, or you write down in your note. Write down these equation and this right side circuit, and then these two, and then you start calculating that one. Then it will be a good practice for you. It will be very clear to you. Are you all writing down? Everybody, please write down or take a picture on your cell phone and then make it hand in front of you. Then you can calculate that circuit. So in particular, everybody write down those four expression. Y11 is ion over V1, Y21 is I2 over V1. For this case, this means just remember that you have to make right side short. There will be I2 current flowing, but V2 0. And then left side there will be ion and then V1. And you write down Y12 ion over V2 and Y22 I2 over V2, and you have to make left side short. There will be ion current, V on 0, but there will be I2 current, and then V2 will present. And then write down these two equations, I on this, I to this. Those will help you to solve the problem. Is everybody fine? So have you written down these things?
Yes.
Okay. So now I am going to that problem. You see, now you obtain the Y parameters for this circuit. Now apply that technique. Find out Y11, Y1, Y21, and Y22. So therefore, to find out Y11 and Y21, what you have to do? You have to make right side short circuit. And then show that V2 0, and then show the current direction, that I2 current flowing. And then left side, you draw a current source that there is ion current, and label the V1 voltage, and then current ion is entering here. So based on that, you calculate that in. Everybody, first you all try, and then I am sharing you that how to calculate. First you make practice. So in this case, because you will be finding the Y1 on Y1, the unit will be in Siemens or mho. You remember? You can express the result in Siemens. These are not the ohm, because Y1 on Y2 on Y22, etc. So let me write down the result here, and that will help you to understand that. I'm writing the answer here. Like I got Y1 on that's 0.75 Siemens. So you see, this is my answer. I got Y1 on 0.75 Siemens. So you all try and see that you are getting. And let me write down all answers. And okay, so then Y1, then Y21. Y21, I got minus 0. There will be minus 0.5 Siemens. Then Y22, I got 0.625 Siemens, and Y12 minus 0.5. Okay, everybody see, I wrote down the answer. So you should be getting these answers. So you see that you are getting or not. I mean, I expressed in Siemens, you might express millisiemens, that is okay, but Then you compare with the result and Siemens events. And keep in mind y21 and y12, that there will be minus sign, minus 0.5, here minus 0.5. Everybody please try, please take your pen and paper and calculator and do these things. So far, have you been able to calculate any of these parameters?
I'm having a hard time with Y21 and Y22.
Oh, so but you got y1 on y22 the same?
Yes.
Okay. So, okay, y21 and okay, keep going. Yeah. So as you can see, for example, why the minus sign is coming? Because once everybody see, once you make the short circuit, for example, right side, I mean, say this one, everybody look, the basic thing. Once you are making short circuit on the right side, then current flowing is this direction. But this is your reference, that if you say this is the positive direction, but then this is the opposite. So therefore for I2, you have to make a negative sign for I2. The same thing for this one, for the bottom figure, when you have this source, second source I2 is present, but you are calculating ion. For ion, you have to give a minus sign. That's why the minus is coming. So now everybody see what you can do. I just told you that why the minus sign is coming, because of the opposite direction current flowing. When you are sorting I2, when you are making sort on this one, then ion is minus. So everybody, just as a hint, you may need to apply the current divider rule as well. Current divider rule. Everybody see, when you are making right side short, just look, when you are making right side short, meaning that your 8 ohm is getting sorted out. So therefore I2 current, because this is short, so I2 current that is flowing through the 2 ohm resistance. Look, if there is I2 here, then I2 will be flowing through the 2 ohm. So therefore, this side, you have the source on the left side when you are making short right side. This means ion is your total current. That total current, something is going through 4 ohm and the remaining is going through 2 ohm. And then all the way that is going through the sorted path. Therefore, ultimately, your I2 is going through, what is going through 2 ohm? Just opposite direction. So you just need to give minus sign. So this means you have to find out how much current is flowing through 2 ohm. So at this point, when you have the current ion, you can apply the current divider rule. That ion, see everybody, ion is your total current that is entering at this point and then getting divided into two parts, something here, something there. You find out what is there. That will be the current I2. Just you need to give the minus sign for I2. The same thing when you will be considering the right side current source is present, but this side is sorted out. Left side sorted out means your 4 ohm is sorted out. So this means in that case current will enter through the 2 ohm. That you have to find out. This means this is your total current I2 that is getting divided into two parts. Some ports on through 8 ohm, some ports on through 2. Apply the current divider rule. You apply the current divider rule. That will give you this, then Y21 and Y12. Everybody keep trying. Yeah. Okay, so therefore everybody see, here see my calculations. So I am sharing. You see, first I made this side short. I assume that ion, there is ion. So I wrote everybody like Y1 ion over V1. What is my V1? V1 is ion multiplied by this equivalent impedance. But because this is short circuit, so 8 ohm is sorted out. So parallel of 4 and 2. So 4 ohm is in parallel 2 ohm. So that I'm writing, you see right side. So V1 is ion multiplied by 4 parallel to this 2. I got 1.33. So ion multiplied by 1.33 volt. So for V1, you see, for Y1, I am writing that thing 1.33 ion. And in the numerator, ion cancelled. So 1 over 1.33, I got 0.75 unit is Siemens. Now, next case, Y21 is I2 over V1. I2 over V1. Now, that is the thing. What is my I2? You see, because this is sorted, I2, which is flowing through 2 ohm. But because in this direction, opposite to the ion direction, that's why I put minus sign. So this means, look here, I have applied the current divider rule. What is the I2 value which is flowing through 2 ohm? This means how much current is flowing through 2 ohm. So I am applying current divider rule here and I put minus sign because I am finding I2 minus. Ion is my total current. So ion multiplied by 4 divide by 4 plus 2 which is 6. So I got minus ion 0.67. That thing I am plugging here. And what is my V1? I already calculated V1 this one 1.33 ion. So ion cancelled. I got minus 0.5. Julian, can you follow now?
Yeah, I think I messed up because I didn't do current division right. And also, if you're doing this right, all the I1s and I2s are always going to cancel out, right?
Yeah. Right. Yeah. Exactly. The same thing happened in the previous problem also. Always those will be cancelled out. Because you see the ion value is not given. You see it is not given like this is 10 or 20. Ion value was not given. So with the help of the equation, you have to cancel it out. That's why, ion, usually you look, ion value is not given. You cannot put it. It's just in terms of variable. Now see the bottom part. Next time you assume that there is current source here, I2 is present, but then left side is shorted. So this means V1 0 and ion is flowing. And again, as I told you, the same calculation. Everybody look, V2 means I2 multiplied by the equivalent, but this is shorted. So 8 parallel to 8 parallel to, so I got 1.6 I2. And then apply the current divider rule for ion here. How much is ion? This is shorted, so how much is going through 2 ohm? So this means I2 total current multiplied by 8, divide by 8 plus 2, 10. And then because I am calculating ion, so I put minus sign. So minus 0.8 I2. You plug in those numbers, then you are getting Y2 to Y12. That's all. Could you follow me, everybody?
Yes.
Yeah. So you should, I mean, not difficult, just to look a little bit carefully, just be very attentive and very carefully. Otherwise, you will be missing. It's just the series parallel combination, current divider rule, and then just the voltage division rule, voltage calculation. That's all. So when you are applying the current divider rule, then be careful. Okay, I2 is coming here and it is divided two parts, something here, something there. Find out this one. And that is for ion. Ion is in this direction. That's why minus sign. Same thing here, I2. I2 was in this direction, opposite to the direction of ion. That's why you are putting minus sign. And the rest of the things, current divider rule, voltage rule, simple Ohm's law or voltage current relationship. That's all. Therefore, if you make mistake in calculating ion or in this, then you will end up completely wrong result. Okay, therefore everybody please, I already uploaded this slide. Please everybody try your best. Again, you all understand these three problems that we discussed today. You all look on the class slides and then video lecture and then try to understand. So next class I will continue. I will solve another 3-4 problems for you. Then it will be much more clear to you. So with that, I think some of you have next class. We are already done. So I am stop sharing here. Do you have any questions, comments?